Hey guys, today we're talking about recursive formulas or recursive definitions for sequences. Now, a recursive formula is simply a set of statements that tells you how to calculate the terms of a sequence. Within that set of statements, you are always going to be given the first term or the first couple terms, and you're going to be told how to calculate the next term of the sequence from the previous terms. Let's take a look at a few examples, and I think it will become really clear to you. Example 1 asks us to generate the first 5 terms of the sequence defined by this recursive formula. So we see that L sub 1 is equal to 113. That's our first term. So I'm going to write that down right here. Our first term is 113. And then the next term is going to be equal to the previous term plus 41. So my second term will be generated from taking the first term, or the previous one, to the second term, and adding 41. And that's going to give us 154. Now, in order to calculate the third term, I need to again add 41 to the previous term, which the previous term now is 154, so that's going to give me 195. And in order to find the fourth term, I'm going to end up by adding 41 again to 195, or the previous term, and I'll end up with 236. And then finally, for my fifth term, I'm going to again add 41 from the previous term, and that will give me a 277. Okay, now keep this in mind. L sub 1 indicates the first term. So they give us the first term in this case. We can always represent the previous term by using this L sub n minus 1. So think about this, right? If you wanted to find the third term, that would be L sub 3. The previous term would be L sub 2, and the way you would get 2 is by taking 3 and subtracting 1 from it. So anytime you see this notation L sub n minus 1, it's really referring to the previous term. Okay, in example 2, we're asked to again find the first 5 terms of the sequence as defined by this recursive formula. The first term we know is 53, and then we're going to take A sub n, our next term, and it's equal to the previous term minus 7. Well, let's start off by rewriting this in the recursive formula using that A sub n minus 1. That would be A sub 1 equals 53. A sub n is equal to A sub n minus 1 minus 7. So this A sub n minus 1 now represents previous term. So 53 is our first term. Our second term would be found by taking the previous one and subtracting 7, and that's going to give us 46. Our third term would then be taking 46 and subtracting 7 from it to get 39. Our fourth term, subtract 7 from 39, and we're at 32. And then finally our fifth term will end us up at 25. Okay, now let's consider the opposite direction. Let's say we are given a sequence of terms and we want to write the recursive definition. Well, remember, a recursive definition always contains a couple of statements. That first statement is the first term. So we want to call this sequence B. So we'll say B is equal to the set of statements where B sub 1, our first term, is equal to 850. Now, let's take a look at the pattern here. What are we doing? To go from 850 to 775, to go from 775 to 700, it looks like we're reducing each term. Now, I think we're going down by 75, so we can say that the next term is equal to the previous term, B sub n minus 1, minus 75. And we'll define this over the range where n is greater than or equal to 2, because we already have our first term, so we'll start at our second term and go from there. All right, example 4 gives us the same thing here. We have a sequence, 324, 108, 36, 12, and 4. Again, it looks like they're being reduced, but not by a constant amount each time, like in the previous example. In this example, we're actually dividing the previous term by 3. So we can write a recursive formula to generate the sequence as well. So we'll say C is a set of statements such that C sub 1 is equal to 324. And then C sub n is equal to 1/3 our previous term, which would be C sub n minus 1. So we're taking 1/3, or dividing our previous term by 3, or multiplying by 1/3, to get our next term. And again, this is going to be defined over where n is greater than or equal to 2. All right. In example 5, we want to generate the first 7 terms of this sequence. Well, you know how to do this by now. you have your first term is 97. It looks like we're taking the previous term and subtracting 23. So go ahead and you find the next 6 terms. All right, in our final example for today, we have the NCAA Women's Basketball Tournament that consists of 64 teams. Each are paired with single elimination contests. At the end of each round of play, the number of teams proceeding to the next round is half the previous round. So let's come up with the terms of the sequence. We know round 1 consists of 64 teams. After that round, there'll be half of 64, which is 32. After round 2, we got half of 32, which is 16, then 8, then there's 4 teams, the final 4, and then finally 2 teams and 1 team remains. So what's a recursive formula that generates this sequence? We'll start off by saying t sub 1 equals 64, and then t sub n is equal to 1/2 times t sub n minus 1, our previous terms. And again, this is where n is going to be greater than or equal to 2. There you go.